Allison, thank you for inviting me in to be a part of this discussion and webinar. I'm pretty excited about getting to share our story within Minnesota and with more specifically Minnesota Department of Transportation. So I am MnDOT State Maintenance Engineer, and we have obviously a long background in using different materials in and equipment in how we fight snow and ice. So I want to go through a little bit about what I'm going to go through a whole bunch of slides today. You're going to get to see some of the internal workings of things we're doing, and I'll kind of explain those as we go. Again, happy to answer any questions that you might have, and I will have my contact information on the last slide too, if you want to grab that at the end. So yes, we are working to drive down salt usage, and that is primarily being done by advancing our liquids program here at MnDOT. So uh, let's see. Make sure we're advancing through here. All right, fantastic. Well, the first thing that we want to take a look at is the best way to reduce our salt use is just keep the snow off the road. So we have a pretty aggressive use of snow fence, both in, you'll see living snow fences. We start out with really kind of that gateway opportunity. We'll meet with farmers if they got corn, standing corn. We'll leave some of those rows up and actually compensate the farmers to get them experienced with the idea of blowing snow control. If we can move from there, we've got options for farmers if they want to continue to do that, of living snow fences as well as structural snow fences. But snow gets on the road, and so we've got to get out there and remove it. And obviously, we run initially mechanical. Everything we can do mechanically, we will. So we've got plow trucks, we've got motor graders, we've got tow plows, icebreakers, which is a relatively new tool that's come on the market in the last few years, and we found that just again another great way to enhance our mechanical removal of efforts. And oftentimes we've got to be blowing snow, especially metro areas where we've got limited space to store snow. We're blowing a lot of snow to haul it away. But out in the rural areas, as we see a lot of drifting occur along our highways where we don't have blowing control activities next to them, we are having to blow things out. Or when our ditches fill up, quite frankly, a long, busy winter, all those accommodations we made to store snow, if they fill up, we may need to actually blow those clean before winter gets done. So again, our motto and mantra is keep it thin. We want to be scrape as close as we can and as frequently as we can along our highways. Obviously, with more than 30 plus thousand lane miles of roadway and 800 trucks running that, it takes a while to get back to each one of those each of those lane miles. So we work hard. We want to plow during the events as much as we can, and when windy situations, sometimes we can't even look at alternative chem or any chemicals on roadway because we actually may make the situations worse. So by doing this, we reduce our barrier lane regain time when the storm does finally end, and it also reduces our chemical usage. Obviously, blades here, there, and everywhere. Front blade, the underbody plow, which is really a workhorse that allows you to put a little extra down pressure, helps, again, keep things as thin as we possibly can. And then we do have a wing, and we run anywhere from 9-foot wings up until yesterday. Our longest wing was 12 feet, but yesterday we took delivery of a wide wing truck that we saw at an APWA show a few years ago, and that is a 21-foot long wing that actually will, with the truck and the wing itself, will cut a path about 27 feet wide. Dual wings on both sides, and then the tow plow, much like the wide wing truck we have now, just gives you us an opportunity to cover more ground as we're running along. I mentioned the icebreaker early on. This is an example with the icebreaker. It just actually mounts right on the front of our standard snowplow in the same spot where our front plow would be. This is just a picture of the front. It's kind of up close to the side. You can just see a lot of sharp teeth that will penetrate the ice pack that we may, compaction that may get built. If you've got maybe an inch or so, it actually can do a nice job of shattering that and breaking it free. But even if there's more compaction and we can't get it actually break up, it does provide great little small pockets for us to come back and put in both solid salt as well as liquid chemicals to help that, again, that removal process. So as you see, after we've gone by with the icebreaker, that underbody plow oftentimes is available or is able to move quite a bit of that compaction off. So how do we remove what remains? And this is the challenge, and this is actually why we're here today, is to talk about salt. Because what do? We use salt. And salt is, is a cost-effective solution. But we also know that it has some. One of the university professor once talked about the challenge that we have is that we've got to take care of grandmas by putting the salt on the road and guppies by finding ways to reduce that amount of salt that we need to the absolute lowest amount necessary. So how about let's look about how can we reduce our fluoride impact to the environment? How about if we reduce our material costs? Can we use less material? And how about if we reduce our payments to normal more quickly? And those used to be competing ideas that we didn't think we were going to be able to done, but we can do that, and we'll show you some reasons on how we can do that. And how do we do that? I'm going to talk a little bit more of just and this is probably standard information for all of you already. I mean, we already know that it's toxic to aquatic life. A lot of fishing going on in Minnesota, and we want to obviously preserve that, but also just take care of even those non-sport items that contaminate groundwater, difficult to deal with. So again, we continue to drive and look for ways to do that. So our challenge is get the material onto the pavement surface, make sure that it stays there long enough to do work. Because anytime we put salt on, and if it's immediately blowing off the pavement into the ditch, we aren't getting any value for that salt. And instead, we're just polluting. And so we got to figure out how much we need in a given circumstance and look at ways that what we can do to reduce to achieve our goals. The four pillars of our program here at MnDOT is we need to obviously produce the brine. Brine is which is the most common and most highest volume of liquid we utilize, just a sodium chloride brine. It's the same salt that we actually put on the road. We actually will have bought higher purity brine or salt for our brine production, a solar salt. Again, that just helps us produce higher volumes at lower costs when we consider the time that it takes to maintain and deal with our brine making equipment. If we've got to take it out of production, do a cleanup, and then resume. So we've worked on that. The next part is that we want to do some storage of that brine. We don't necessarily want to go directly from the brine production system into the truck. We want to have some storage because that allows us to take care of blending. And again, I'll touch a little bit on that a little later on. Then once you got it, you got to get it on the road. And it doesn't do any good until you can get it actually on the road and be a part of it. But that fourth pillar is really building and sharing our collective knowledge. And this is why we're big advocates and big believers of the FHWA Snow Conference, as well as other activities. MnDOT is the host state for Clear Roads, which is actually 40 states across the country that get together and deal with snow and ice efforts. And that is a way that we, as I often joke, we are big into R&D, which means not research and development, but more rip off and duplicate, because there's a lot of great stuff that's getting done across the country, across the world, quite frankly, and we want to leverage that as best we can. So just an example, how much does MnDOT salt do we use? We average a couple 100,000 tons per year, 220, I think, for the last 14 years. Our lowest year was 114,000 just a couple of years ago. That was more driven by a very mild winter. Our highest in 2013, we went over 324,000 tons. So, what Mother Nature decides to provide for us, we've got to deal with it. And so trying to find the best way to be the most effective as we can on that. So I'm going to skip on that. I'll bring that slide back a little bit later. But the first thing is we had to get over the you are nuts hump with many people. If we talked about advancing our liquids, you're going to put water on top of ice. Don't you know how slippery that's going to make it? And we kind of did work the math for them and said essentially a pretty high application is 50 gallons a lane mile. We've got some that will apply a little bit even higher than that, but it really only leaves about a thousandth of an inch across a roadway lane mile. And actually what happens, all we're doing by adding the liquids is we're just advancing the speed in which that liquid's going to work. And that's how we get back to the idea of a better regain time. So getting to salt, in order for it to work, it has to be in direct contact with ice, must be in a solution. You can actually get some melting at that physical solid salt to ice barrier, but as what we've seen from researchers at the universities is the idea that if you can get a brine on there, you will dramatically increase the impact and the melting that we can do. As it melts, though, you imagine that it's now going to dilute that brine. So the brine that maybe came out at perfect 23.3% salt in it is going to become less and less effective. So we have additional salt that's available in that slurry to continue to dissolve and then continue to make things work. So that's kind of our way we're using it. Again, why do we want to use liquids initially? Liquids were used just to reduce bounce and scatter. It's the idea of coming out of the back end of the truck. You're driving down the road at 25, 30, 35 miles an hour. You want to make sure that when it comes out of the truck, it stays there and doesn't just bounce off into the dish. So we get that advantage. Then we're gonna see obviously that activation that I talked about before. By getting liquids on there, it will just speed that up, and we can reduce our usage, lower our cost, and we can actually reduce our working temperature. And that's where we talk about a material like a calcium chloride liquid that we will blend into our materials. And by doing that, one of the things we've also been able to do is bring carbohydrates into the mix. This extends the time that we're able to reduce stuff. So I want you to try it the first time when you got your nuts hump. Take a couple of styrofoam cups, put the same amount of salt in each of those cups. Add water to one of those, and just let it sit overnight. When you get a chance, walk out on the driveway, dump it on the driveway, and you will watch the difference and start to become a believer in what brines can do and how much more effectively and quickly they do work. You know, I'm an engineer, so I got to bring geeky, and we got to bring in a couple of slides in here. You'll see versions of this phase diagram a little bit, a couple times here through the presentation, but salt becomes less and less effective as you get lower temperatures. And in fact, at -6, you are done. There's no melting that's going to occur with a sodium chloride brine. That is absolute perfect. And even that melting that occurs much below 10 to 15 degrees Fahrenheit is so much slower, it doesn't work. It doesn't work as well. And so what we're going to be doing is we're going to, as we talked about, diluting that more as we melt it. And we want to stay in this world where we've got more salt that's available in the mixture, so we can melt. If we have too little salt, it's going to refreeze. Too much salt really isn't a problem from a brine perspective because it just comes out and becomes more solid salt for us to do. But once you get too cold, it just simply isn't going to work. And so this is that tug and pull that we go. As we put it down, it begins to melt the ice. The salt is becoming less effective. If we have additional salt, that's solid salt that's available to dissolve, we can again drive that melting point down. And so that's why we do some direct liquid applications, but most of our work is done in the world of slurry, which is a high volume of salt, or a volume of salt and a higher volume of liquid than what we would traditionally do. So this just shows the idea of why we make that jump from solid salt, so from sodium chloride to a calcium chloride. Mag chloride does some good things for us too, but it gets really funky also at around 25 to 30 degrees Fahrenheit. It can actually get slippery. So we limit our use of mag chlorides. We're primarily a calcium chloride stuff. We do use some potassium materials in one of our blends, and we actually are using potassium acetate on some automatic de-icing solutions on bridge decks, as well as on a couple of routes that we're doing some test work on right now. This just talks about that time effect conversation. If you see on that chart, if your pavement temperature is up around 30, you can melt a lot of ice and you can do it very quickly. But as it gets colder, it just becomes less and less effective. And so time is an important piece for us. And also, quite frankly, on a roadway, time is a problem because traffic will end up dragging some of that material off. And many of those who drive on the roadways understand that some of that salt just gets deposited on the side of our car, and we're back at the car wash getting it done. But why do we want to add sugar? Sugar does nothing to help melt, but it does refreeze or slows the refreezing of ice as that dilutes. So or dilute, excuse me. One of the things I want you to try at home. This is kind of a fun one. If you put, again, you have to have an understanding and spouse in the room in the house and pay attention to it. But if you put a can of Coke and a can of Diet Coke in the freezer, what you will find is that can of Diet Coke is going to freeze a lot faster than the can of Coke. And in fact, when you go to McDonald's, this is maybe a little safer. Go to McDonald's and order a Diet Coke slush. You can't. Diet Coke slush won't work, but they will have a regular Coke slush, and it is because that sugar just allows a little bit of that to be around. So I'm going to again, they're talking about this idea. This is that same graph that we were talking about effectiveness with a sodium chloride. When we get to calciums and other materials, we can actually drive that down quite a bit more, and actually driving some of those ag products bring some other things to it. Another thing that comes that is some of the research, some of the institutions they've talked about is the idea that the viscosity of that fluid changes slightly. And one of the things that will, and a really cool example, I think this came out of Montana, that by having more of the sugars in it, this is by they just set snowballs into, again, some of these are great high-tech experiments, which as a maintenance guy, I love. Grace shows a picture, but as you've got more and more carbohydrates in there, that will actually draw up into your snowpack and helps solve, or it helps both the amount of material that may stick around later on for treatment, but also just talks about how it's slowing that whole process. We want to be able to look at, the ideas of if we can have residual product remaining on the road. Obviously, these first few winter storms are challenging because there's no salt that's sitting on the roadway. But as the winter goes on, and especially if it's a busy winter and we're out there a bunch, we're going to get some of that residual effect. The other cool piece about adding sugars to it is it really has a major impact on corrosion itself. And so these, again, are just some examples of the more ag type products you can bring into this, you actually have the entire liquid itself is much less corrosive. So we like to look at that. And so this happens to be just one of the products that came out of the work that Clear Roads had done, and just an example. So when we talk about using these chemicals, whether we're using salt or solid salts or liquids, we're not trying to melt everything off the roadway. Again, I started out the idea, let's get out there and mechanically remove. That's the big spot we want to do first. They're the primary piece, but de-icer will help us break that bond. And in many types, we can actually, by pre-treating in certain applications in certain locations, we can reduce that amount even more because we don't even allow that bond to create. So in a perfect world, there's a lot of speculation, the conversations, we may be able, if everything was great, we might be able to have almost a 75% reduction in the amount of salt that we use. Now, again, it's never perfect, and it's quite a journey, but we have shown effectively that we can actually make some pretty big jumps, big bites out of that. So you talked about the idea that anti-icing, this is when we talk about just putting a liquid only down before a storm. We will do that more often in urban areas. Bridges are big spot, intersections. Rural areas that may be exposed to a lot of wind, we're not necessarily going to do that. But then de-icing and pre-wetting, this is the kind of the stuff that we had done for many, many years since we started using liquids in Minnesota in the 90s. And we use it as a smaller amount, just kind of in this de-icing process. But what we're talking about here is a much more higher volume output, which is a higher amount of liquids combined with some solids, or in fact, even direct liquid applications. And we've got some shops that have gone, 2 or 3 months into a winter before they actually applied their first solid salt to the roadway. The types of snowfall events were occurring, they could take care of it, was just simply plowing and direct liquid applications. So a lot of the things that we're talking about, we do some pretty high end and high extreme brine production, lots of different items on the market. Storing it, obviously we've got to be able to store it up. So when it comes time to have a winter event, that we're available and ready to go. And this is also allows us to, the calcium type products are much more expensive, in the range of 6 to 10 times more expensive per gallon. So we don't want to use it when we don't need to use it. So on a 28.5-degree storm, solid sodium chloride brine, perfect, works great. But as the temperatures start to drop, we need to look at ways to add additional chemicals into that and go it. So this is kind of one of our standard plow trucks. Plow trucks are based on hauling solid materials. Salt and sand have been our mainstays for decades. But now we are trying to find ways to get more and more liquid. So we're taking space on the side of the truck to put that. We've got inbox tanks in many of our ones, and then we also look at other ways to make that happen. Here's an example of that inbox tank. If we're going to use less salt, we can put some of that storage inside the tank, inside that hopper for liquids, and then we want to bring it out on a saturated, almost look like an oatmeal, like when it gets onto the roadway. Or we may actually do the direct liquid. Pay attention to the idea that these nozzles are evenly spaced across the roadway. That's where we started with the idea, and it works great for an anti-icing process. But as we've learned from other people, that sometimes that's not a great de-icing solution. So I'll show you that a little bit later. This is a city partner and the neighbor. Again, the idea of how do we mix it? How do we bring it to the truck? Side tanks, mixing it right at the discharge point. We'll have spinners on many of our trucks, but most of our trucks don't actually use spinners anymore. We used various types of chutes to get that discharge as close to the pavement as we can. So again, the idea of reducing bounce and scatter. The tow plow, in fact, is something we talked about. You saw this picture earlier. I bring this up because our initial tow plows, you can see we put a liquid tank on there and a solid tank. When Minnesota buys a tow plow now, there's no solid tank on it anymore. We've eliminated the idea that we're going to add. There's enough solid material inside the truck to accommodate anything we want to do there. We're just going to have more and more liquids, and that liquid can either be pumped forward into the truck to mix with the salt, or it can be applied directly as a liquid. And in fact, we will use our tow plows as an anti-icing effort. As you see this example, not only can we treat the lane that we're in, but we can create the lanes to either side of us. Or we may just have a truck that does the same thing, only a tanker truck. Again, something we will use. We use a lot of work with modeling, weather forecasting, and a maintenance decision support system where we try to provide some clues and some ideas. The operator has direct control and final say of what goes on the roadway, but we want to give them as much information that they know. So our temperature's about to rise. Maybe we can back off. Temperature is going to drop extremely, and we want to hit it really hard at the beginning part of a storm so that we aren't dealing with compaction, some of those things as the storm winds down and gets cold. Talked about the idea of research, and we do both with our work within Chloride as well as ourselves. We'll do a lot of what I refer to as maybe more theoretical or university-based research, but oftentimes we want to just do some stuff in the field, and sometimes we even blend them together. I want to talk about a cool facility that we have at Camp Ripley in central Minnesota, where our state patrol has a test track, or it's a track where they use for all of their training of their state troopers. 2-lane section that winds around, does a lot of interesting things. But what we love is they've got a 4-lane section that sits about a 1/4 mile in length, and it's a roadway that we can take much higher risks in our treatment efforts. And then we bring additional vehicles in and just make a treatment and then continue to circle around to simulate the effect that traffic can do. Traffic can hurt us and help us when it comes to de-icing. And in many situations, when we do it right, we can actually make the traffic help us out. So the first thing we did is went out there on a hot August day, 95 degrees, and we wanted to do some scatter testing. And so we went that in the summer of 2021 and just kind of developed some ideas of profiles. What would be the best ways to get material out so it doesn't scatter a lot, and then understand what speed impacts as well as what liquid impacts we would have. We followed that up with some just the salt and slurry testing. We did a direct liquid testing in winter 23. Winter 24 never showed up. So winter 25, and actually now into winter 26, we're doing some alternative chemical testing. I want to just run through a few of the things that we saw there. Here's an example of just the idea by having that slurry. how much more effective we were at 30 miles an hour. And those, if you're looking down at those graphs, the green indicates the first 4 feet from the center line of the roadway out. The yellow indicates the next 4 feet. The orange is the last 4 feet of a travel lane, and the stuff that's in red, that's wasted material. That's just going, we're putting it out on the shoulder. We don't need to treat the shoulder, and all that's going to do is end up being a problem for us. So again, this just reinforces the idea of that we really need to be looking at slurry type solutions to the greatest extent that we can, as fast as we can get our equipment turned over, which is on a 15-year plow truck life cycle. It gets to be a bit of a challenge. So that forces that. So our first test that we did in winter, we put essentially 500 pounds on center dry granular material on one way, and then we put only about 320 pounds of salt on the other side. So about a 30% reduction of what we were doing, and let's just see what happens. And so one of the things that was kind of cool on that, when we got to the end of it, it absolutely validated our impressions that we saw, just the way we saw the melting occur. But it also talked about we had 31% less salt. Obviously, there's a cost and environmental savings there. But the roadway got better faster. And that was the aha moment. Frankly, it just confirmed a lot of the things that our operators had been reporting over the years as they increased their own use of liquid, because they were saying, hey, I can get my roads better. I'm available to help out my coworkers. And it was a spot here where we could actually put the numbers to it. So one of the things this did is it unplugged the ability for us to go to the legislature the following year and say, hey, we need more money. We want to do this faster. The second year is, as I mentioned, we want to look out what's happening. And we really love what's happening in some of the counties in Wisconsin. Obviously, Jefferson County is a leader that we see, but other counties are doing some really great work. And so let's take some of the advantage that they've talked about about direct liquid application and some of the lessons that they're learned, and let's go apply those. And one of the cool things I mentioned, the most common direct liquid application, again, we're looking down on a lane here, was to have those nozzles spread evenly across the truck. And we said, you know what, Jefferson County had brought all of those towards the center line, which, as we sat back and thought about it, that's where we've been dumping our solid material for years. We've known that we dump it in the center line of the roadway, and then traffic and gravity as the natural drainage of a pavement will bring it over to the side, and we'll actually have some better performance. So let's go do that. And here you can see on the I want to say the left side, the westbound, is we got 8 gallons on the center line, and here, excuse me, that's the Jefferson County solution. Essentially, we were looking at. We put that 80 gallons at the center, and on the other two, we treated the lanes separately, 40 gallons on each lane. And after an hour's work, we're starting to see some good work. They're both kind of working. But what's really cool here is if you look 3 hours into the event, even though on the left-hand side, we only applied our liquid to a very narrow portion of the roadway, just the natural movement of traffic has actually cleaned up that entire surface of the road much faster than what we saw with the concept with the spread out solution. So as we upgrade new trucks and look at more solutions, we're looking at moving more and more of our direct liquid application to keeping that at center line. The one we're in the process right now, and this is a mixture. It's a Minnesota State University Mankato research project that is entering its final season. And we wanted to come in and talk about, let's try to quantify some of the effect of the alternative de-icers. And there's a gob of them. You can see, BT, Chloride, SOS. There's a lot of them out there on the market. We don't want to pick market winners and losers, but we wanted to make sure that we understood them, what was happening there. And so what the neat thing about this is it just pumps a lot of those different ions. You've got mag chloride, calcium chloride, sodium chloride, potassium chloride. In the Minnesota form of that beet heat material that we were testing, we have asked them to pull the mag chloride out, and then it adds 4 different types of sugars, and it's a different material, and it's very highly controlled. We have, as we've been using this more over the many years, we've been able to find a very consistent expectation of the product. So when we go out to use it, we know what we're going to see. So let's just run through some of the things that we were looking at. So we kind of wanted to look at, how do they work great? There's a cost. How do we look at that? So the MSU Mankato first went into the lab and took a variety of different mixtures, and let's both take a look at mixtures of different ages. We had materials around the state where we could say, hey, this is the same material. How did it look? And for the most part, looked really good. With the carbohydrates, you will tend to get a little bit of fermentation that occurs. The professor notes that the idea that it starts to smell a little more brandy over some time. Not that we're encouraging it to drink it, but it's certainly that's one of the things that are going on. But we did notice that it actually worked pretty well regardless of age. And then as we looked at different concentration, what kind of performance would we have with those materials? So again, this is a 20, I think 21 or 20, 21 degree Fahrenheit below zero. And actually the full bead heat, we could never actually get it to freeze. So did a variety of different things, but that's kind of cool. They talked about how we can do different capacities. We understood how much ice melt capacity you could get. Again, this is great laboratory work we want to take a look at, but it really has to get out into the field. And so again, they went up to Camp Ripley, and we wanted to have it be cold testing. We didn't need to test at 25 degrees Fahrenheit. We wanted to be 10 degrees or less. And we waited and missed an entire year. And in fact, came last year, and let's let it go on. They had a good snowfall. We were all excited. We're going to dispatch everybody in. And then we showed up the next morning, and wind had come in overnight and blew the snow off the road. We have a lot of people here ready to go. And we said, we're not going to quit. We're going to go back, and we're going to plow that snow off of the roadway that's off the road, and we're going to bring it back on the road, and we are going to make our own little slush and do a whole lot of other testing. As I mentioned, we'd spend a lot of time in that 4-lane section. The researcher had to call an audible and said, here's my test sections. We're going to pull the snow onto the 2-lane sections, and we're going to go out and create some snow and ice. So here's us reverse plowing, bringing snow back onto a roadway, running over with a tanker truck and putting a lot of water on it because it was a light powdery snow, and we wanted to create compaction. And so we drove around and we worked into the night, came back the next morning at dawn, and we had a beautiful ice field to pay at. This is the skid pad area, and then which we did some testing, and then also we did some work out on the roadways. And so here's just different types and different ways to apply material. We wanted to be able to evaluate those. We put a bunch of civil engineering students out there on the roadway, and some very good, we were 9 degrees the entire day. And they were just out there looking at, pictures of applications, but then also going down and looking and describing what type of ice they were seeing and taking thousands and thousands of photographs. And it was a great way for us to, in the end, as we were producing all of this fake compaction, in the end, when we came back the next morning, we were there, and we gave us a platform to work from. We want to go back and do a little bit more work as we were taking a look. Here's an example. You can just see we wanted to run lots of vehicles, so we had our trucks as well as lots of vehicles running along the pavement to simulate traffic. So here's an example of one. I think this one is about, let's see, 200 pounds lane mile of rock salt, 30 gallons of lane miles of slurry, which was, I think, a 70-30 blend. And you can see after 30 minutes, after 50 minutes, we see things start to open up. 75 minutes, it's getting even just a little bit better. And then now we're about 95 minutes, and it's probably time now to go in and actually start plowing that material off. So the big pieces we learned that, and we did a variety. I got enough slides for you already, but we did this in a variety of different concentrations, a variety of amounts of salt that we used. And so kind of the cool thing that we saw as we're looking at this is we saw some initial moistening starting to happen 5 to 30 minutes into it. So indeed, we knew that things were happening, but we needed to make sure we didn't get on there and plow it off too quickly. We needed to let that material work as long as it was staying on the roadway. We saw no refreeze in our material, which was important for us to understand that, it's one thing to melt it, but we wanted to make sure that it doesn't refreeze before we can come back and do it. Obviously, we all know the sun is awesome. It can help us out. The big piece here, and I think the bullet point in the lower left-hand side, is that on this test, regardless of the amount of solid salt that we had in there, we saw no significant difference. So again, why put 350 pounds of lane mile out there when 200 pounds of lane mile would have been sufficient? So again, this is going to really have, we think, a dramatic effect in the comfort level of our operators to say, hey, we can dial it back. As long as we're getting enough liquid on there, we can back off the amount of solid salt that we need to do at. So cool things that we saw in that world. Again, the idea that we can do the brine just fine, but we need to look at the idea of more softening that occurs. And then, excuse me, I want to grab that one slide here. We really talked about the idea as we got colder, that melting capacity is not as much, but we didn't need to melt it. We just needed to soften it up so it became easier for us to peel it off. And that's why that classification and those close-up photographs by those students was fantastic and very helpful. So obviously we knew always plowing first. Brine helps distribute the ions more rapidly so we can start that melting. We take some time and traffic to help us out, but below 10, we're going to focus on that whole idea of softening to a plowable hardness. And obviously, depending what kind of snow you've got, how much moisture is in the snow, all of those things come into play as we're actually getting into the real world. But so I want to go back and now so what does all of this stuff mean for MnDOT? Well, here's some average salt usage that we've had over the past few years. You can see we've got 23-24 season, or we call it fiscal 24. That's our lowest that we've had in at least the last 2 decades. Now, a lot of that was weather driven, but you can see that usage jumps up and down. You also can see if you take a look at liquids, our liquids have continued to trend up, but there's a fluctuation up and down. So is it better? Are we doing stuff better? And one of the things that we have worked through is the idea is, how much, when we look at total gallons for the 5 years, 2012 to 2017, we were really around that 3 million gallons statewide. We started advancing it up in 2015. 5.8, 6.5, 6.6, 8.1, 14 million gallons in 2023. Nasty winter for us, very difficult one. Big drop in 2024. And then this last winter, about 12.3 gallons. But as we looked at that, we're trying to have an hard time to say, what makes sense here? And we started playing around with the idea of, we want to make more liquids and less salt. So we're going to put liquids in the numerator, salt in the denominator, and we're going to develop a ratio. And how does that ratio, that ratio change over time? And so we ran, and in fact, this one only goes back to 2012, but actually even years before that, our ratio, we were locked in at about 10 to 15 gallons per ton. That was our pre-wetting stuff. That's all we did. But as you can see, is we have a progressive and steady march up. 41, 43, 54, 86, 89. And again, and this really depends on where the snow is occurring in the state and how far that district is in its liquids program. So what we're finding is by looking at this ratio doesn't help us much in an event because in an event, you're going to be looking at what tools do you have available. Is it direct liquid? Is it just high slurry? What's going to be necessary for that event. But as you're looking at a total season, how things are going for you. So that's just been a push that we've done. You can see the wide variety of distributions of really, some districts have had a very advanced program over the years. A couple of districts, much higher volume of use, but the other ones are starting to catch up and kind of close that gap. Kind of how did we come up with that originally? We knew we were putting we thought we could get to 30,000 gallons a year, 30 million gallons a year. And so we thought, well, okay, we can save in 30. Okay. And a year that would require that much material, we maybe could be looking at only about 154,000 tons as opposed to what we were doing before. So we said, what the heck, we're going to throw a 200. And then we've actually started to back calculate and look at not only ourselves, but we worked a variety of other states in an NCHRP study here recently looking at performance metrics. And we're seeing that there's other states that have more advanced amounts of liquids that they are using are seeing that threshold of 200 plus. And in fact, we've got one truck station that routinely is 500 gallons of salt per ton of solids or liquids per ton of solids they're putting out there. So this is certainly the piece that we're going to look at. We've got set a goal for 200. We aren't going to get there by 2027. That's really triggered. That's if somebody would have dropped 300 or $35 million of cash in our laps. And we didn't get the 35, but what we've got is a steady amount of support from our top staff as well as the legislature to put more and more money into liquids. So is it achievable? Absolutely. Many areas around the state have been able to exceed that 200 gallons a mile for the whole season. So with that, that's our story in Minnesota, stuff we've got going on, and be happy to answer any questions you've got, either as a part of our webinar today, or if there's, feel free to reach out to me. So Allison, I'll turn it back to you.
All right. Thanks so much, Jed. This is great. 90 slides there. Is that right?
Yeah, I'm not, I like to click.
You said you would move. You did. So yeah, I have a couple questions here while the people who are watching are still like a few slides behind. It's just part of the lag that happens. But the first one, if you could go back to when you started to talk about, I love all the data and the experiments happening at Camp Ripley. It was great. At one point, there was a slide that said 200 pounds per lane mile and 30 gallons per lane mile. But then like the following slide shared 20 gallons per lane mile. And I was just wondering, yeah, if I misread that.
What we tried to do during them, and even I won't go back to the specific slide, but what we had is each of those segments along that area where we're doing the testing, we controlled differing amounts of liquids and differing amounts of material. And solid material. And what we wanted to really get an idea of how much liquid it took. And so we would say that we would love to be everybody over 20 gallons a lane mile if they can. Now, you got to be able to produce the brine. You got to be able to store the brine. You got to be able to have the trucks available to put it on the road. So a lot of things have to happen in order for that to come true. And if you can actually pump up to 30 gallons, hey, I'd love that. 30 gallons a lane mile. I'd love to see you get there. But one of the things, probably the big thing that we noticed in the research this last year is that regardless of the amount of salt that we added when we were, again, at 9 degrees Fahrenheit, we didn't see a benefit over time to adding more solid salt. So none of these are prescriptions to say this is what the right answer is, because every storm is going to be different. What we have found is that we've got to continue to do this work. We talk out loud with our supervisors, with our employees. We actually had the MSU professor get out and meet with all of our supervisors across the state and many of our employees this fall to share preliminary results. And the big one for us was to simply say, it gets cold, stop putting solid salt down on the road or reduce your amount greatly. It will be helpful. And we did see some helpfulness. It was different. Liquids only did not perform at Mine Below as well as the slurries. So we want to have some of the solid salt available, but we just know that we can back off our solids. One of our districts they've been very advanced in applying a lot of liquids, but they've been a little slower on backing off the solids. We expect them to have a monstrous year because they've got all the tools out there. They're just going to start putting less salt down, and we should see some great jumps in their ratios that they're going to perform over this winter. So again, all of this stuff will be a research project that will actually close next summer, and that data will be published, and people will be able to understand what's the different things that we saw. And again, we're not knocking on wood that we'll have a good chance to go out and do some additional testing to validate this stuff with natural snowfalls this upcoming winter.
Well, And yeah, just a reminder to everybody, as you do finish kind of the plan presentation, feel free to put any questions, comments that you have into the chat, and then I'll be able to ask those of Jed. So, Jed, I guess a part of this then, I mean, is like you said, the cost of this equipment, right? If somebody was going to give you hundreds of millions of dollars, you'd be able to change the fleet over and
Right.
give everybody those tools. So, what would you say is kind of that? I want to say like kind of like dream truck right now, like the patrol truck that's set up to have the liquid capacity that you need to hit those target rates. Like, do you have a photo of one of the trucks that was used that you could share with people, or if you want to share kind of like the stats of like how much granular salt capacity and how many gallons of liquid on a truck?
Yeah, I can touch on that. With
Mhm.
the 800 plus trucks that we have in our fleet, there's really not a dream truck. Oftentimes, one of the things that we for decades were about 50% tandem axle dump trucks and 50% single axle dump trucks. Single axle dump trucks don't have, obviously, they can't cover they don't have enough as much material on it, but their mobility is great. And so we kind of had a blend of both. The advantage that the tandem axle truck, it carries more weight, and it's also one that we can put a lot more liquid on. So we've gone from about a 50-50 blend to our production right now of new plow trucks. We produce it's about a 14-year life cycle. So 57 trucks a year. We're producing about 75% of our new trucks are tandem axle trucks, and about 25% of them are single axle trucks. And then we will match them up depending on what the roadway characteristic is for each of those given shops. We've also added a lot of trailers. That's one of the things I didn't include in the picture. And again, the great thing we got out of the state of Iowa is the idea, well, let's just tow a small trailer behind us, much like we do with our tow plows, and that's going to haul 3,000 gallons of brine, and we'll just pump that material up to the truck. And so now the truck we've got routes that we have some routes that are as short as maybe 12 miles that a truck will cover, but we've other routes that are over 100 miles, just depending on the geography around the state. And so now we can cover a lot more miles, have more liquids on them. And so it really gets to be I've talked about it as a dance. You got to really look at where are your reloading points? What do you need from that truck? We just know that, for example, we're going to put a spray bar on now. We're going to find a way to concentrate that spraying at the left side of the truck normally, because that's going to ride close to the center line of the roadway. Or if we have it perfect, we're going to be able to go left or right. We'll decide that in the cab. The operator, if he's working on a multi-lane roadway, can again put that material in the right spot. So flexibility is key for us, and trying to find ways to. We've got a variety of different inbox tank designs. We've got you saw I had showed tanks that are just saddle tanks that sit on each side. We also have false bottoms where we'll put 500 to 1,000 gallons just on the bottom of the box and have salt on top. And we've actually built a few now that are actually wedge tanks where we actually have a higher volume of liquid in the front and a lower amount in the back. That actually helps the material move much easier out the back of the truck. We don't have to lift the box of the truck as high as we'd like to. Lifting a box up in the air puts you a good chance of running into a bridge, and we'd rather not run into bridges with our trucks. So again, trying to find all of these different things that make sense. We have to haul lots of snow. We can't have inbox tanks because we need that snow storage. So again, there's no perfect tank, but what you got to do is really look at what you can do in your world to have the flexibility to be able to respond to all the different storms that may be thrown at you.
Yeah, and I guess I'm just asking if you could throw out kind of like an example or two in terms of liquid capacity on a single and a tandem. Because
Yep.
when I go around and I talk to a lot of folks, there are people obviously who are just straight up granular right now. Some
Yep.
people maybe have that 100-gallon tailgate tank, and I'm trying to tell them, yeah, you're limited, right? If you only have 100 gallons, like you can kind of spit on the salt a little bit, right? You got
Exactly.
way on the other end here. So can you just give people like a
We've
couple
got
of
we've got some tandem trucks that go over 1,000 gallons of total liquid capacity, both in the side saddle tanks. You usually limit to a couple hundred pound or a couple hundred gallons. That is the most you can get on the outside. But if we can start adding tanks inside, we can add more and more to that where we can. And again, that's where We just have to take a look at all of the things. The truck is still a general vehicle. It's doing traffic control, it's doing snow hauling, it's doing patching, it does a lot of uses throughout the year. I'm really excited about our new wide wing truck that we're bringing in. Not only is it wide, but it actually has a live bottom on it. And instead of the material coming out the back of the truck, it actually comes out in front of the three axles. So we actually drop the salt onto the roadway and we will immediately run over it with that truck, which again, if there's solid material, will help grind it into that snowpack so it can do its work there instead of doing its work when it gets to the ditch. So again, trying to find all those different little things. So as much as we'd love to have that perfect truck, we know that we
I
don't.
understand. It's like there you need to have multiple tools,
Yeah.
but just trying to give people some ideas about,
So
where you're at.
so one of the things I would say from a truck, if what I would love to be able to say is it size it such that you can get 20 to 30 gallons of lane mile of material out and of liquid out. That's a lot of liquid if you got a 100-gallon tank. You're going to go, or not a lot of liquid. You're going to go 3 miles and boom, now you got to refill. But we can't turn around and refill that fast. We've got to find a way to cover your route. So if your route length, if you're only got a 12-mile route length and you can come back and you can refill quickly, maybe you can get by with just a couple 100 gallons. But what we're really pushing is the idea that we want to be looking at 4, 6, 800,000 gallons on a truck where we can, in order to have a reasonable amount of time on the road before you got to come back and refill. Or if you're really lucky, put a 3,000-gallon tank behind you on a trailer and just tow that trailer around all day long, and you'll be able to go a lot further. So those are the things that we look at, and kind of that whole paradigm of what does that plow truck look like for you. And we're seeing a lot of states are going to, and we've got a couple where we have just only liquid tanks on them. We put a plow in the front, an underbody underneath the wing, and we just got a liquid tank on top. And that works great when liquids are appropriate. If there's times when liquids won't work for you, then again, that will be a challenge. Because one of the things, if we get a high wind condition, we don't want a lot of moisture, free moisture sitting on that roadway, because that will actually start to collect snow.
Yeah. Well, yeah, I mean, I think what you're saying definitely in line with, if people haven't seen it in the past, we've got some webinars with Bill Kern from Jefferson County, as you already pointed out, a real leader in liquids. Also, Barry Pierce from Walworth County. I know their trucks now, I think, are 1,400 gallons of liquid capacity. And they're like you running that really high, they call it like a hybrid instead of the slurry, right? But really high rates of direct liquid, with really dialing down their granular.
Yeah,
So,
and I think that's part of the challenge in that what is defined as a slurry. And that's a lot of work that we're doing on the national level with both AASHTO, as well as other groups, just trying to talk about what's a hybrid, what's a
yeah,
slurry,
what was
what's
the
a shake and
terminology?
bake,
Yeah,
what's yeah.
yeah,
There's
exactly.
we
And there was a comment here. Love that you are testing things out to give confidence about applying new ideas in practice! Exclamation point. Thanks for your leadership. So, wanted to pass that along. And I don't see other comments or questions here that have shown up on my end. So I did just see a pop-up that you've got another meeting to go to here at 1. So
oh,
I I think we can let you go, but I know you've got your email and phone number there. So thank you for sharing. Thanks for this as the the attendees share. Thanks for your leadership, and hopefully run into you at one of the next snow conferences.
absolutely. Take care. Be well,
All right,
everybody. Good luck.
bye, Jed.